Hello dear students, in today's video we are going to study regarding the last topic of chapter number 9 optics. Name of the topic is optical instruments. So in today's lecture we will see introduction to the optical instruments, then concept of magnifying power, and depending on which the two types of optical instruments we usually use, simple microscope and compound microscope. So at the beginning we will see some introduction to the optical instruments. Suppose we have an object which is having a size which is not necessarily depend on the distance of that object from our eyes. याकरता आपण एक्झाम्पल घेऊ शकतो. ह्यूज माउंटेन असेल किंवा एक स्मॉल ट्री असेल. Suppose that huge mountain is located far away from us, but the small tree which is close to us. So because of that distance, the difference in the distance, the mountain even appear smaller than a small size tree because that tree is located near to us. तर याचं reason काय असेल? The angle subtended by the mountain to our eyes is smaller than the angle subtended by the tree at this position. Okay, so because of the angle, that visual angle which is subtended by the object from its position to our eyes is important. Okay, so that is the limitation of the distance only, and because of that bigger objects are also can appear very smaller because of large distances from our eyes. यानंतर नेक्स्ट कन्सेप्ट जी असेल ती डिस्टन्स ऑफ डिस्टिंक्ट विजन नावाने ओळखली जाते. डिस्टन्स ऑफ डिस्टिंक्ट विजन इज डिनोटेड बाय कॅपिटल D फॉर unaided and normal human eye. The value of distance of distinct vision is about 25 centimeter. Okay, when we focus any object at our eye lens, it is not possible for our eye lens to see that object closer than certain distance. That exact distance is 25 centimeter. Okay, distance of distinct vision. Now if the visual angle is made by that particular object to our eyes is less than 25 centimeter, our eye is not enough to see that object clearly. Okay, and if the object which is very small, suppose we can take the example of leg of an ant, it will make visual angle which is not enough to see it through our eye. And on the contrary side, if we consider any cosmic object, okay, अंतराळातला एक कुठला तरी ऑब्जेक्ट जर आपण कन्सिडर केला जो आपल्या डोळ्यांपासून हा अति दूर असेल, फॉर such objects we cannot bring these objects closer to us, and also we cannot make out minor details by using our eyes only. So for that purpose some optical instruments are used. These optical instruments are telescopes or microscopes. Now with the help of these optical instruments you can increase the visual angle. Okay, जो visual angle large distance वरती असलेल्या ऑब्जेक्ट्सला आपल्याला स्मॉलर ॲपियर करत असतो, या व्हिज्युअल अँगलला इन्क्रीज करण्याचं काम या ऑप्टिकल इन्स्ट्रुमेंट्सपासून केलं जातं. आणि याच फिनॉमिनॉनला अँग्युलर मॅग्निफिकेशन असंही म्हणतात, ज्याला आपण मॅग्निफाईंग पॉवर असं म्हटलेलं आहे. सो मॅग्निफाईंग पॉवर इज नथिंग बट द रेशो ऑफ व्हिज्युअल अँगल मेड बाय इमेज फॉर्म बाय द ऑप्टिकल इन्स्ट्रुमेंट मीन्स बीटा अपॉन व्हिज्युअल अँगल सबटेंडेड बाय द ऑब्जेक्ट when kept at small d. capital D rather, which is least distance of distinct vision, and that angle is alpha. तर बीटा आणि अल्फाचा जो रेशो असेल ज्यालाच मॅग्निफाईंग पॉवर म्हटलं जातं. तर या मॅग्निफाईंग पॉवरवरतीच नेक्स्ट कन्सेप्ट जी आहे सिम्पल मायक्रोस्कोप ती डिनोट असेल. फॉर सिम्पल मायक्रोस्कोप we have to consider some lenses or some instruments that are commonly used to see very small size objects. Okay, for example, watchmakers can use convex lenses. Okay, to see very tiny parts of the wristwatch they use some lenses, and these lenses are actually work as simple microscope. These simple microscopes are also called as reading glass. In this given diagram we can see the visual angle alpha is there. So AB is the object which made angle alpha with observer. Okay, that's why the object appear very small. Now in the second diagram if we see, one convex lens is used. Because of that convex lens, angle beta is created at the focal length of that lens. We can see the object AB and the rays passing through the convex lens will form the image of that object at certain distance. Okay, here in this diagram U is the object distance and V is the image distance. So image will appear at distance V and the size of that image is magnified. Okay, जर आपण इथे बघितलं AB हा ऑब्जेक्ट असेल आणि AB1 is the image, then that image is obviously magnified. So this is how visual angle beta is made. That angle is actually greater than alpha. So magnifying power is given by the ratio of visual angle of the image to the visual angle of the object when at distance of distinct vision. That's why m is equal to beta upon alpha. For very small angles alpha and beta we can write tan of beta and tan of alpha. If we look at the diagram, tan of beta can be written as opposite side upon adjacent side. For this case, tan of beta can be taken as BA upon PA, and also in first diagram we can see tan of alpha is BA upon D, that is opposite side upon adjacent side in this right angle triangle. So value of magnifying power will be capital D upon U. That is considered numerically because distance U, which is negative, if we consider sign convention नुसार लेन्सच्या लेफ्ट साईडला जे डिस्टन्स असतात ते निगेटिव्ह असतात. दॅट्स वाय वी हॅव कन्सिडर हिअर न्यूमेरिकल व्हॅल्यूज ओनली. सो फॉर मॅग्निफाईंग केसेस, फॉर द केस ऑफ सिम्पल मायक्रोस्कोप, there are two limiting cases. First one is for maximum value of magnifying power, that means capital M max, while the second case would be minimum value of magnifying power, that is capital M minimum rather. For the maximum magnifying power, the image should be at distance of distinct vision. Okay, the image distance will be capital D. That's why V is equal to capital D. But here, as image appears at distance negative from the lens, we can see image appear at left hand side. That's why V will be minus D, and obviously the focal distance F is same for both the object and image. That's why F would be plus F, because focal length is on the right hand side of the lens, and also the object distance will be negative because object is kept on the left hand side, and the magnifying power is M max as the limiting case suggests. So for thin lens we have the formula for focal length 1 upon f is equal to 1 upon v minus 1 upon u. If we replace all the values given in this case in above equation of thin lens, we can finally denote d upon f is equal to d upon minus d plus d upon u. Here after simplification we get maximum value of magnifying power m max as d upon u, okay, because d upon d is 1 and that is 1 plus d upon f. So this is how m max will be there. This is for maximum value of magnifying power. Similarly for minimum magnifying power, the image distance is infinity, okay, v is infinity. That's why if we keep that value in a value of above equation, 1 upon f is equal to 1 upon v minus 1 upon u. Here v is infinity, that's why 1 upon infinity is 0, and numerically we can write f is equal to u because minus sign will be considered for sign convention. That's why u is equal to f, and automatically the equation for minimum magnifying power comes out to be equal to d upon u, that is nothing but d upon f. So using these two limiting cases, we can say that the value of focal length must lie between d upon f, that is minimum value of magnifying power, and 1 upon d upon f, that is 1 plus d upon f, that is maximum value of magnifying power. म्हणजेच अँग्युलर मॅग्निफिकेशन जे असेल ज्यात आपल्याला फोकल लेंथ ही या दोन व्हॅल्यूजच्या मध्येच बघायला मिळेल. एका एक्झाम्पलवरून आपण हे कन्सिडर करू शकतो. ह्युमन आयसाठी कॅपिटल डी 25 सेंटीमीटर असेल, दॅट इज डिस्टन्स ऑफ डिस्टिंक्ट विजन, अँड इफ वी कन्सिडर द फोकल लेंथ इक्वल टू 5 सेंटीमीटर, म्हणजे फोकल लेंथ 5 सेंटीमीटर असलेल्या लेन्ससाठी आपल्याला इमेजमध्ये किती मॅग्निफिकेशन मिळेल ते आपण या फॉर्म्युल्यानुसार घेऊ शकतो. कॅपिटल डी इज 25 अँड स्मॉल एफ इज 5. सो मिनिमम मॅग्निफाईंग पॉवर इज 5 अँड मॅक्सिमम विल बी 1 plus d upon 5, that is 6. So image will appear only to be 5 to 6 times bigger than a lens of focal length, for a lens of focal length 5 centimeter, and for minimum d upon f is equal to 5, and if we take the image distance as infinity, and the ratio of image distance to object distance will be infinity because v is infinity. So the magnification in image size must be infinity, but the minimum magnifying power would be 5 times bigger only. Okay, image would appear at infinity, even the image distance should be infinity and the magnification would be only 5 times. So this is the advantage of using convex lens in simple microscope. And for maximum magnifying power m max, the value would be equal to 6 for the same distance. But if we use image distance as 25 centimeter, v is equal to minus 25, and therefore u must be minus 25 upon 6, and the magnifying power would be 6 times larger in this case, because v upon u is 6. Image size is also 6 times that of the object and also appear 6 times larger. So this is case of maximum magnifying power.